In a regular database, if you want to delete 6 months of old data, you run a delete query. It scans millions of rows, it logs table, and it takes time. In a time series database, you delete 6 months of old data maybe by just dropping a folder. Instant. No scanning, no locking, just done. This is because of time-based partitioning. When data comes in, the database doesn't put everything in one giant file. It splits storage into chunks, and each chunk holds data for a fixed time window. An hour, a day, a week, depending on the database and your configurations. InfluxDB calls them shards, TimescaleDB calls them chunks. But the concept is same. Each partition is completely a self-contained unit on the disk. Its own files, its own index, its own compression. Now think about what happens when you want to delete data that's older than 90 days. In a regular database, the old rows and the new rows are mixed together. So you have to find them one by one and then remove them. In time series database, all the data from January is in January partition and all the data from February in February's partition. To remove data from January, you just drop January's folder. The database doesn't touch a single row. It just removes that partition from the disk. This is called retention policy. And most of the time series databases let you set it once. The old partitions get dropped automatically. And it's not just the deletions. The queries get faster too. If you are asking for data from last 24 hours, the database knows from which partition it should be pulling that data. It skips everything else entirely, just the relevant chunks. Write-ahead log compression partitioning. The storage layer of time series database is complete now. Part 4 is around indexing. How your database finds your data amongst millions of series without scanning everything. So see you all in the next video.